So let's begin the semester. Okay, and we'll begin by reviewing Newton's laws. So first question, ilang laws meron si Newton? Okay, meron bang makakasagot nun? Okay, sana ganun lang kadali yung exam, ano? Yes, thank you for your answer. There are three laws of motion. Now, how were they described sa Physics 101? Sa Physics 101, they were described in terms of, well, first of all, yung title nila. Law of inertia, yung first law. Law of acceleration, yung second law. And law of action-reaction, yung third law. Okay, we're also going to do that, or we'll also retain yung mga titles na yon. Okay, but i-revisit natin yung Newton's laws na yon in terms of how they should be interpreted. Okay, so yung first law, if you recall, a law of inertia states that an object at rest will continue to remain at rest, and an object in motion will continue to remain in motion. So dalawa yung dito, unless an external force acts upon it. So dalawa actually yung tawag dito, yung ine-encompass nitong law na ito. Okay, and a body that is not moving at saka a body that is moving but is in constant motion. And when you say constant motion, walang acceleration. Okay. Ang idea dito is when we say na walang forces na nag-act or merong zero force or unless it is acted upon by a force, it means ang implication nun is ang net force is zero unless it is acted upon by a force. Okay, ang implication nito is net force is zero. It doesn't mean na walang forces na nag-act dun sa object na yon. Okay, it only means that if you add all those forces vectorially, okay, yung net force na nag-act dun sa object will not cause it to accelerate, will not cause it change direction or change in speed. Okay, so yun yung implication ng law of inertia. Okay. Now, law of inertia tells us also something about not just about the motion, but also something about yung mass ng object. And alam naman natin to na tawag dito, the more massive an object is, it's harder for that object to start moving. Okay, and basically it's because of inertia, di ba? Mahirap itulak ang isang truck, mahirap paandarin ng isang truck by just pushing on it. Okay, kumpara sa isang kotse, for example, if you push on it. Okay, mas madaling pagalawin actually ang kotse. So that tells us something about the relationship of mass and inertia. Okay, they are related, and it's not just causing tawag dito an object to move, but it's also causing this also applies to when objects are already in moving and then you want to stop, gusto niyo pigilan yung pag-move ng object. Okay, kung gumagalaw yung isang object, mas mahirap patigilin yung object na yon kung mas malaki yung kanyang mass, right? I mean, kung merong binato sa inyo na baseball, okay lang na saluhin yon, di ba? Pero kung merong iba to sa inyo na bowling ball, medyo hindi na okay siyang saluhin, kasi mataas yung inertia niya, malaki yung mass niya, at mahirap pigilan yung kanyang motion just because malaki yung kanyang mass. Okay? So yun yung implications ng law of inertia. So it's not just about an object that is not moving or that is not accelerating, but it's also about the mass of the object. Yung second law is the law of acceleration. Sa Young and Friedman, ang tinuturo sa atin is the net force. Okay, remember that this is the net force. Okay, net force is equal to the product of mass times acceleration. Nung ginawa ni Newton ito, he actually didn't define it as such. Dinefine niya ito as dp dt, where p is the momentum of the object. Okay? Ang sinabi niya is that the rate of change of momentum is equal to the force of the object. Okay, ang ibig sabihin nito is this implies na yung force ddt is related to the changes not just in mass but also in momentum. Diba? So kung titignan natin ito, pwede natin ito isulat in this way, diba? And m dv dt. Okay, now oftentimes itong component na to, or at least sa 101, ini-ignore natin to kasi wala namang changes dun sa mass. I mean, saan ba kayo nakakakita ng moving object sa ordinary na scenario, okay, na kung saan yung mass ay nag-change, di ba? Pwede nyo i-argue, okay, yung vehicle, nagmabago yung mass niya kasi yung mass is converted, yung gasoline or yung diesel is converted into energy that is being used up by the engine. At nagiging production ang kinalalabasan niya is yung combustion, di ba? So yung gas is converted into energy and then goes out as tawag dito, products na lumalabas dun sa likod ng kotse. Okay? So nababawasan yung mass nung object. So the mass changes. But if you tawag dito, we typically ignore that kasi ano ba naman yung mass ng gasolina kumpara sa mass ng buong kotse? Ang isang vehicle, for example, is about 3,500 kilograms and yung gasolina is what? If you put 60 liters, then it's just 60 kilograms. So it's just less than 1% yung change na yun. And typically we ignore that. So sa everyday scenario, ini-ignore natin itong part na ito. And dun sa mga problems na na-encounter nyo sa Physics 101, okay, yung component na yun is ignored. But here, dito sa 161, we are going to take a look at that component carefully in a few problems na isosolve natin. Like, for example, pag mag-shoot ka or pag papadala ka ng rocket into space, okay, now yung fuel na kailangan para paliparin yung rocket into space. Now, that's considerable. Okay? And so, alam natin na considerable yun kasi once the rocket is in space, pa-consume niya na lahat ng fuel, yung fuel na, yung pinaglalagyan ng fuel ay madedetach na dun sa rocket. That's how much the weight of the fuel is compared to yung weight ng buong rocket. Okay? So, hindi na siya pwedeng i-interact. Okay, so yan yung real definition or yung definition ng force ng second law as defined by Newton dun sa kanyang book when he tawag dito, when he made itong three laws of motion niya. Okay, let's see. So gusto ko lang gumawa ng bagong slide. Slide. And dun sa third law, ang third law is law of action-reaction. Okay, now, ito yung isa sa mga mahirap intindihin, okay, base sa mga estudyante and base sa mga exams or understanding ng mga estudyante, previous students, okay, na na-encounter ko sa 161, sa 101, okay, and even sa physics 100, sa applied biological physics ng mga bio students. Okay, mahirap intindihin ang action-reaction even though it's quite straightforward, okay. Ang idea lang dito is pag may isang force na nag-act sa isang object, may isang force due to the first object na nag-act on a second object, yung second object na yun will apply an equal amount of force but in the opposite direction. Mathematically, we write it as this. Okay, so F is equal to F1 is equal to negative F2. Okay, kung saan yung F1 is the force acting on acting on the second object by the first object. Okay, and yung F2 is the force acting on the first object by the second object. Negative yan kasi negative sila. Opposite yung direction ng forces. And for this law of action-reaction to be applied, there always has to be two objects, object 1 tsaka object 2, that are acting against on each other. Okay, it's oftentimes confused pag nagsosolve ng problems, pag nagsasum kayo ng forces, for example, along the x-axis, and nagsusulat kayo dyan ng lahat ng forces and then i-equate niyo sa MA. Sometimes it is applied here, okay, yung third law. Okay, kasi sinasabi ng mga students na okay, pag ginamit natin yung third law, pag in-add natin yan, magiging zero lahat yan. Okay, dahil sa third law. But it's not actually correct because the usage of this is on one object only. Okay? Ito ay parating sa dalawang objects. Always on two objects. Okay, so yun yung fundamental difference. Okay, and these two objects do not have to be in contact with each other. Okay, pwede silang tawag dito. Like for example, when you jump, di ba? Pag tumalon kayo, hindi na kayo in contact sa surface ng Earth. Di ba? So, halimbawa kayo ito yung surface ng Earth, tapos kayo yan tumalon, kay kunwari lang na ganyan kataas yung talon ninyo. So, non-contact na kayo. Non-contact na itong dalawang objects na ito. And bakit kayo bababa? Kasi merong force of gravity, force, okay, due to Earth on you pag tumalon kayo. Yung reaction force is force due to you on Earth. So you're actually exerting a force on the Earth. Di ba? So kung isipin nyo, ganyan ba talaga ako kalakas? Di ba? Kaya ko bang hilain talaga yung Earth? Okay, naintindihan niyo yung question? Kasi according to the third law, if the Earth is pulling me backwards, then I am also pulling the Earth towards me. Diba? Pero bakit ganon na hindi naman gumagalaw yung Earth at ako lang yung gumagalaw? Well, the thing is, diba? So mass 1, so this is force exerted on, ang tawag dito, on object 2, diba? So dapat mass 2 to and acceleration 2 yan. Bakit may negative yung plus? And this is, itong F2 is force on mass 1. Okay, and acceleration ng mass 1. So ganyan yung essentially nangyayari. Pero kung halimbawa kayo to, ako yan, mataas yung acceleration ko, and in fact, yung acceleration ko is g. At kung ito yung Earth, okay, bakit yung Earth ay walang acceleration? Di naman siya nag-move towards me. Well, the difference is, ito maliit ang mass, ito malaki yung mass. So kung maliit yung mass nito, at malaki yung mass nito, and equal silang dalawa, then this acceleration needs to be very large, and this acceleration will be extremely small. So much so na hindi mag-move yung tawag dito, yung Earth in the very small amount of time na nasa ere kayo. Diba? So, hindi nyo makikita, hindi natin mararamdaman na mag-accelerate talaga yung Earth. Okay, because of its very massive, because of its extremely high mass. And that's also because of the first law, diba? Kasi sa first law of motion, yung inertia tells us that it's harder to move a massive object, okay, compared to to an object which has very small mass. Okay, so ganun yung nangyayari dito. That's how you apply the third law of motion. Now, using the definition of Newton, so dp1 dt is equal to negative ng dp2 dt. Okay, if we rewrite this further, if we expand this, okay, sabihin natin m, okay, assume na yung mass is constant. Okay, and m1 and m2 dv2 dt, may negative sign dyan. Okay, and then of course itong dv1 is a, di ba? m1 a1 is equal to negative m2 a2, or we can write this as saan ko ba isusulat? m1 over m2 is equal to negative a2 over a1. Okay, so ang sinasabi dito is that the ratio of the acceleration of these bodies are opposite to each other kasi may negative sign, and yung ratio nila, yung magnitudes ng ratio nila is a constant, and that constant can also be defined by the ratio of the magnitudes of the masses of the two objects. Okay, so yan yung isang implication din ng third law of motion. Now, the third implication is this. Okay. Starting again from this equation. So pwede nating isulat ito as this, diba, equal to 0, or P1 plus P2 is equal to 0. So, ano ibig sabihin nito? Let P1 and P2 be the total momentum. So, capital P. Okay. P, capital P is the total momentum, P1 plus P2. dP dt is equal to 0. Anong sinasabi nito? So, the rate of change of the total momentum is 0, which means that if we integrate that with respect to time, this total momentum is constant in time. Okay? Anong tawag natin dito? Meron bang nakakaalam kung anong tawag natin dito sa law na ito? Or merong nakakaalala? Sinong nakakaalala? So, yes, this is called the conservation of momentum. Momentum is conserved. Okay? So makikita nyo na from the third law, maraming naging implications. Okay? in terms of mass, in terms of yung momentum being conserved. Okay, now so yun yung tatlong laws of motion natin. Now I'd like to go back a little bit sa mass, okay, ng object. Kasi sa 101 ini-ignore lang natin yung effects ng mass because parati nating sinasabi na the mass doesn't really change and anong tawag dito is just a constant and so on and so forth. Well, in fact, it does change. Kung nag-104 na kayo or kung hindi pa kayo, kung mag-104 pa lang kayo ngayon, you'll encounter what's called theory of relativity that was developed by Albert Einstein. And dun sa theory of relativity niya, the mass changes with respect to velocity. Okay, so sa theory of relativity, yung mass is actually a function of the velocity. Okay, the higher the velocity of an object is, the higher the mass of an object is, until it approaches the speed of light. At which point, yung mass na yun ay mo-convert into energy. Okay, so yun yung tinatawag natin or yun yung interpretation ng E equals mc squared. Conversion of mass into energy. Okay. So, itong mass na ito, ang tinatawag actually dito is inertial mass. Meron pang isang type ng mass which is called gravitational mass. Okay, and if we're talking about speeds, normal speeds na na-experience natin sa normal na scenarios, itong mass na to, okay, is approximately equal to the normal mass na na-experience natin for speeds very much less than the speed of light. So kaya natin kayang i-ignore yung tinatawag na inertial mass. And oftentimes, sinasabi natin na yung inertial mass na yan is just the same as the gravitational mass. Pag sinabing gravitational mass, it's just the mass that is defined based on the effect of gravitational forces between objects. Pag sinabi natin inertial mass, it's the mass that is defined based on the motion of that object given a specific force. Kaya itong mass na pinag-usapan natin nung una na mass na related sa relativity is an inertial mass. It has nothing to do with gravity. And in fact, pag pinag-aralan nyo na yung theory of relativity, makikita nyo rin na gravity actually adjusts, okay, dun sa or the mass of an object, or gravity actually adjusts dun sa mass ng object. Okay, because according to third law of Newton, to the theory of relativity, the higher the mass of an object is, mas malaki yung curvature ng space and time, and that curvature of space and time is actually yung gravitational or yung gravity as we understand it. Okay, so it will be interesting to study itong mga bagay na to pagdating nyo sa theory of relativity. I think sa 162 nyo pag-aaralan itong topic na to in a deeper manner. 162 or 181, sorry, 181 pala. Okay, so yun. Any questions so far? Now, any movement, okay, will require a reference frame. Okay, so meron tayong tinatawag na frames of reference. We have to use a reference frame if we want to describe a motion. Okay, so ang tinatawag natin typically sa reference frame yan is an inertial frame of reference. Ganito nyo lang isipin ng frame of reference. Typically, ginagamit natin dyan is Cartesian coordinate system. So X, Y, at saka Z. Okay, now, yung frame of reference na yan can either be have zero velocity or non-zero velocity but zero acceleration. Oops. Zero acceleration, so it's not accelerating. So constant yung speed. Ito. Constant speed. And if this is the case, then we call that an inertial frame of reference. On the other hand, pag nag-accelerate na yung frame of reference mo, which is what is happening dun sa general theory of relativity ni Einstein, okay, then you have a non-inertial frame of reference. So pag non-inertial frame of reference, then tawag dito yung tawag dito yung coordinate system niyan is moving and the acceleration is not zero. Okay, so nandun yan sa general theory of relativity. Okay, now typically ang ginagamit nating frame of reference sa 101 and even dito sa first part ng 162 is an inertial frame of reference. Okay, and because we are using an inertial frame of reference, we can relate any motion, okay, with respect to each other, okay, through these frames of references. Okay, ang tawag natin sa principle na yun is Galilean invariance or the principle of Newtonian relativity, special theory of relativity. Pag Galilean invariance, in other words, so halimbawa, ganito. So nakasakay tayo pareho sa vehicle. Kayo nakasakay kayo sa isang vehicle. Ako ay nakasakay din sa isang vehicle. Okay? So I'm moving, let's say, for example, at 10 kilometers per hour. Okay? At kayo, gumagalaw kayo at 20 kilometers per hour. Okay? And both of our reference frames are inertial. Okay? So, ano ang ma-measure ko na speed ninyo? Ang ma-measure ko na speed ninyo is 20 kilometers per hour minus yung speed ko, which is 10 kilometers per hour. Okay, so that would be 10 kilometers per hour. Ano ang ma-measure nyo na speed ko? Ang ma-measure nyo na speed ko is 10 kilometers per hour minus yung speed niyo, which is 20 kilometers per hour. So yung speed na ma-measure nyo na speed ko is negative 10 kilometers per hour. The negative sign simply indicates kung aling direction yung isang object na bumove relative to the other reference frame. So, with respect to my reference frame, kayo nag-move forward. And with respect to your reference frame, ako nag-move backward. That's why we have that negative sign. Okay, so, and that works, okay? And we measure the same thing because we have, tawag dito, the same inertial frame of reference. Okay, now imagine, okay, just imagine if yung frame of reference ninyo ay nag-accelerate. Okay, magiging incorrect na yung measurement ko. And ganun din yung measurement ninyo. Okay, kasi makikita nyo na nag-accelerate na yung reference frame ko. Okay? And ako, makikita ko rin nag-accelerate yung reference frame ninyo. Pero magiging mali yung measurements natin, okay, dahil ang isang inertial frame of reference, ang isang frame of reference is non-inertial. Okay, that's actually what happens sa special theory of relativity. Okay, merong tinatawag na twin paradox. Okay, at yung twin paradox na yun, basically ang sinasabi is kung meron kang kung twins kayo at ikaw yung isang twin ay nasa Earth at yung isang twin ay pinadala sa isang spaceship. Okay, at ang tawag dito pinalipad yung spaceship na yon, or let's say over 10 years. Okay, and babalik yung spaceship na yon sa Earth. Okay, ang tanong dito is sino yung mas matanda? Kasi according to the special theory of relativity, an object that is tawag dito that is moving at near the speed of light experiences slower time. Okay? And relative sa twin na nasa Earth, yung twin niya na nasa spaceship, okay, is moving at the speed of light. So dapat siya yung mas bata pagbalik. Pero relative naman dun sa twin na nandun sa spaceship, nagmo-move din naman yung twin niya near the speed of light. Di ba? Relative sa kanya, near the speed of light. Pero, so pagbalik niya, ang in-expect niya is yung twin niya na nasa Earth, siya yung magiging mas bata. Turns out that ang tamang sagot is yung twin na nandun sa spaceship, siya yung mas magiging mas bata. And that's because yung twin na nandun sa spaceship ay mali yung interpretation niya about what is happening to yung twin niya dun sa Earth. Bakit mali yung interpretation niya? Because his inertial frame, his or her inertial frame, is a non-inertial reference frame. That means that his or her inertial frame is is accelerating. Kailan nag-accelerate yung spaceship? Well, the spaceship has to return, di ba? And if the spaceship has to return, ibig sabihin mag-change siya ng direction, ibig sabihin nag-accelerate siya. Di ba? So, yun yung problem. And in that case, pag meron ka ng non-inertial frame of reference, mag-iiba entirely yung interpretation mo. And that's something that you will study pagdating sa general theory of relativity. Okay, so pagdating dito sa frames of reference, pagdating dito sa topic na ito, it's important that when you describe objects, moving objects, kailangan yung i-describe in terms of its inertial frame of reference. Okay, so now how do we use Newton's laws? Okay. So yung naka-outline dito na steps, walang pinagkaiba dun sa ginagawa niyo sa Physics 101. Okay, ang ginawa niyo before is unang-una, syempre tinignan niyo kung ano yung problem, binasa niyo kung ano yung problem. Una niyong ginawa is gumawa kayo ng free body diagram. And for you to be able to make a free body diagram, kailangan yung i-identify muna yung forces. Diba? So identify first the forces involved that are acting on the object. Okay? Tapos, i-draw nyo lahat ng forces na yun on that object. Then you write also the given quantities. What do you know? Diba? What do you not know? Ano yung kailangan nyo i-solve? Then you use whatever equations that you need para i-solve yung problem. Of course, ang unang-una nyo ginagamit na equation is the equation from Newton's second law of motion. Okay? And sometimes, ginagamit nyo rin yung kinematic equations dun sa Physics 101. Okay, and then you use some strategies, whether mathematical or physics principle, you apply the physics, okay, dun sa problem para ma-figure out nyo kung paano i-solve yung unknown na quantity. Okay, then once makakuha na kayo ng working equation, then you put in the actual values, okay, for the assumed variable names para makuha nyo yung hinahanap nyo na solution dun sa problem. Okay, so let's begin with this problem. Okay, so this is a very simple problem, a problem that I'm sure na na-encounter nyo na several times sa physics 101. Okay, ang problem na ito is just a block sliding down an inclined plane, okay, without friction, and yung inclined plane has an angle of 30 degrees. Tanong lang dito is, what is the block's acceleration? Okay, so ano ba yung mga forces na involved dito? Since the block is touching the object, touching the surface, then meron kang friction between them. Walang friction, diba? So no friction, but meron kang normal force between them. And then, ang hindi nawawalang forces as long as nasa surface ka ng Earth is the gravitational force. Okay, And to be able to draw the free body diagram, kailangan nyo rin mag-drawing ng coordinate system. So we're going to draw a coordinate system typically that is tilted. Okay, ito yung nakasanayan. Pero bakit nga ba natin tinitilt ito? Actually, the reason for tilting the coordinate system is not because, anong tawag dito? Well, actually, because para mapadali. Pero paano niya napapadali? Mapapadali niya to by decreasing the number of terms per component. Okay? So yun yung gusto mong gawin. Kasi if you use a coordinate system that is not tilted, okay, let's do a blue coordinate system na hindi tilted. Yan. Tignan nyo kung ilang forces along the y-axis, let's say. Meron kang component ng normal force along the y-axis, and then meron kang gravitational force. Tapos, along the x-axis, meron kang component ng normal force along the x-axis, and then meron ka ring, or wala ka ng gravitational force. Okay, so here it's not really a problem, but in some tawag dito, in some other physics problems, nagiging problema dahil dumadami yung components ng forces per axis. And that's why you tilt the axis para ma-minimize, para kumonti yung number of forces. Okay, so yan yung reason kung bakit natin tinitilt yan. Okay. Just carefully erase this. Okay, so ganyan yan. So yan na yung ating free body diagram. It's also important to tawag dito, identify kung ano yung positive axis tsaka negative axis sa both y and x axis. Okay, so nag-move siya from here to here, a distance x. Okay, so ang tanong dito is, what is the block's acceleration? So anong typically ginagawa natin dito? We break the forces down into components along the x tsaka y axis, di ba? Along the x axis, ano yung force na meron? Fg sine theta. Okay. Walang friction. And since this is accelerating, di ba sabi rito, the block is accelerating and it's only accelerating along the positive x-axis. So meron kang acceleration along the x-axis. Okay. Now, here is what's going to change pag nagsolve tayo ng problem sa 161. Okay, so we're going to write Fg. Okay, sorry. Sine theta equals mx double dot. Now, anong ibig sabihin ng double dot na yan? Ang ibig sabihin lang ng double dot na yan, ang ibig sabihin ng dot, if you put it on top of a variable, is that you're taking the derivative with respect to time. So, ang v dot is just derivative of v with respect to time, and ang x double dot is the derivative with respect to time of x. Okay, the second derivative with respect to time of x. Okay, so yan lang ibig sabihin ng mga dots na yan. Okay, so here we have Fg sine theta is equal to mx double dot, or second derivative ng position. Okay. Now, let's take a look at the y-axis. So y-axis, so physics 101, ang ginagawa natin is normal force minus Fg cosine theta. And this is of course 0 kasi walang movement, walang acceleration along the y-axis, di ba? Hindi naman nag-vibrate yung block na yan along the y-axis. So what we get here is n is equal to Fg sine theta. Okay, so medyo straight forward yung ano na to, problem na ito. So n is equal to Fg sine theta. Now if we use this equation, we have x double dot is equal to Fg over m is times sine theta. And since fg is mg, then ito magiging g sine theta. Okay. So, and since sine theta is 30 degrees, the ibig sabihin, g sine ng 30 degrees is just g. Yung x double dot is just g over 2. Okay, so the acceleration, the Bloch's acceleration is 4.9 meters per second squared. Okay, so anong naging difference dun sa pag-change ng notation with using x double dot kumpara sa acceleration? Well, of course, kung acceleration ang hinahanap natin, walang gaano magbabago dyan. But if we, for example, consider, for example, an additional question. Okay, let's say, ano yung expression for the velocity ng object ngayon? Okay, alam na natin yung acceleration. Ano ngayon ang velocity ng object or initial velocity ng object or velocity ng object? Okay. So, anong gagawin niyo dyan? Well, typically ginagawa niyo is you use kinematics. Di ba? So, sinasabi niyo na v squared minus v naught squared is equal to ax x minus x naught. Okay, and then if x naught is equal to 0, and then ang ax is nakuha na natin as g sine theta, tapos v naught is also equal to 0. Okay, lahat yan at time t equal to 0. Then v squared is equal to 2g sine theta times x. Diba? Okay. Now we can also derive this from this equation, from the working equation na nakuha natin kanina. So x double dot is equal to g sine theta. Okay, how do we do this? So ang gagawin natin is multiply natin to by x, 2x dot. Both sides. Okay, so 2 x dot x double dot is equal to 2 g sine theta x dot. Okay, now here's the trick. Itong term na ito is nothing but the derivative with respect to time ng x dot squared. And we can check that, di ba? Kasi d dt x dot squared is just 2 d dt x dot, and then you use chain rule, sorry, d dt, and then you use chain rule, sorry, kailangan natin mag chain rule. So 2 x dot d dt x dot, okay, which is nothing but 2x dot x double dot. Okay, so we use chain rule here. Okay, para hindi kayo malito. Okay, so this is now 2, the left hand side, the right hand side will become sine theta d dt of x. Okay, so both sides ngayon ay meron ng d dt. So we can integrate both sides. Ano ang limits of integration? Okay, t equals 0, 0, 0 yung velocity. Remember, this is velocity. Okay, and yung final velocity, let's say v squared. Okay, and v squared yan kasi d dt x dot squared dito. Okay, dito naman at t equals 0, 0 yung position, and x is the final position. Okay, so yan yung limits of integration. Dito naman natin makikita yan. So, in-apply lang natin yung initial conditions na yan dun sa limits of integration na yan. Okay, and what do we get? Okay, pag in-integrate natin ito, of course, mawawala yung dt na yan. Pag in-integrate natin yan, we get x dot squared from 0 to v squared is equal to 2g sine theta 0 to x ng x prime. Okay, so x prime. Okay, so which means this is v squared is equal to 2gx sine theta, or v is equal to 2gx sine theta square root. And you compare that there. Okay, so pareho lang yung nakuha natin. Okay, so I'm going to leave it here for now. Okay, I'm sure na it will take for you a few minutes para pag-aralan ito, kung paano nangyari yung steps dito. I encourage you very much to review kung ano yung steps na nangyari dito, and if you have questions, pwede nating i-discuss yan dun sa next na meeting. Okay? So, meron kayong current questions related sa naging discussions natin? Any questions kayo so far? Okay, wait. Okay, so walang questions? Okay, kung wala kayong tanong, then I will see you online again on Thursday at 6 p.m. Okay? Yes, i-upload. Ang question is, i-upload nyo ba sa VLE yung slides? Oh, i-upload ko yung slides sa VLE kasama nung video. So, may video tayo ngayong araw, no? I-edit ko lang yung video ng content, then i-upload ko na siya sa VLE along with yung slides na ito. Now, all of these, kung ano man yung pinag-usapan natin dito, ay nandoon din sa book. Okay, so if you feel na tawag dito kulang itong slides na ito, go to the book and read kung ano yung na-discuss doon. And kung kulang pa rin yun, i-discuss natin sa next na meeting. Okay? So, kung wala nang tanong, have a good evening. Ito na yung magiging buhay natin sa buong semester. 6 to 7:30 tayo. And tsagain na lang natin yung isa't isa. Okay? So I'll see you on Thursday at 6 p.m. Thank you.